Welcome back, everybody. I'm going to talk to you today about pre-computed lighting inside of Unreal Engine. First, why you would use pre-computed lighting. The beautiful effects that you can see from Lumen in the current development lighting system that they have that ships with Unreal is wonderful, but very costly on the user's end. So there's great ways to use Lumen, and I think that it's probably going to become more standard as computer hardware gets stronger. But there's still many cases where people are trying to play games on lower end systems, or you're pushing to a lower performance platform like a mobile device or a tablet. And so for those reasons, you might want to consider that pre-computed lighting offers you more flexibility in the way that you structure your game. So let's take a look at some of the ways that we can implement this. Before we get into using pre-computed lighting, we need to enable it in the project. So we're going to go up to Edit, Project Settings, and under Render, we scroll down here, Engine Rendering. We can scroll down a little bit until we can see the global illumination option. So dynamic global illumination method was originally set to lumen. We set that to none. And because of that, we're going to use the reflection method instead of lumen, set that to none. And then we're going to scroll down a little bit further down to where it says miscellaneous lighting. And under allow static lighting, we're going to checkbox that to true. Once that's true, Unreal is going to prompt you to restart the engine, and you can come back. And once you do that, you can start working around with static lighting in the way that we have it set up here. So you'll notice that the lights I have in this room, if you look at them, they're all set to static, right? And so this is allowing us to determine that these lights are going to definitively bake their effect onto the surfaces that they're touching. And so the attenuation radius that you're using for a light definitely matters, because if I have multiple conflicting lights, that can potentially create hazards in the light map, and we'll show that in a little bit with stationary lights. So looking at this, I have a bunch of static lights. If everything's static or everything's runtime, there's no problem. Once you start mixing in stationary lights, light maps become an issue. So the idea of this light here is shining in the space. I have shadows being cast. The shadows are producing a text on the ground, and it may be hard to see here, but what it's saying is preview. And that's just showing that it's not actually the lighting solution as the engine's going to calculate it. This is just what it thinks it would look like if you did moderately decent level lighting. And we can control the lighting level that we use by going up to build and saying lighting quality. We can choose the different qualities. I would suggest starting with preview and getting your entire visibility set in. And then as you go into do refined lighting, stepping up in increments, not just jumping straight to production, because it does increase the time it takes to render substantially. Before I go into render lighting, I also want to point out that outside of my level, or outside of my space here, I have a light mass importance volume. This is one you can get from the place actors panel. If I type light mass importance here, this is just a volume that you click in and you drag and you size to contain the area that you want and the engine to focus on in terms of light mass resolution. So if you have lighting in a space that's less relevant, you may exclude it and it'll get lower quality lighting. So with this in place, I also have my wall here that has a reflective property to it, and I have a reflection probe here. I'm going to start by deleting that probe, but you can see that this is no longer able to show the reflection. Because we're not using screen space reflections or ray tracing, it's going to need to have some sort of reference for what it's supposed to look like when it is reflecting a surface. And we can get those out here by pulling in a reflection probe. There are box reflections, which can be used to give you a nice perpendicular reference into a space, which is good for walls, floors, and ceilings, but you can see some distortion in the way that's being represented. We can also pull in a sphere capture, which is going to be the mainstay of what you use for reflections, which is basically pulling a set of pictures in a cardinal direction, stitching them together, and whenever you look at a surface that's affected by that reflection probe, then it's going to show you the opposite direction from that reflection probe of what it sees. So it's less about the player and more about the probe. And then we have the planar reflections, which these are going to be used for mirrors and pools and things like that. So we're not going to be messing with those today. With the reflection here, I can just choose to build a reflection. I'm going to start by placing the reflection probe kind of right next to this helmet, I think would be a good point to make here. So if it's right next to the helmet, when I go build reflection, you'll notice that the reflection that I see here is this giant representation of the helmet, because it's just showing me the image that's taken from this capture. So if I wanted it to look a little bit more appropriate to the surface that I have, then I'm going to move it closer to that surface so it'll capture an image from that location. If I say build reflection captures, now the reflection capture looks a little bit more like that because it's taken from where the player is going to be, and the reflections I see are more proportionate to where I would expect them to be at this distance. All right, with that being said, let's go ahead and build lighting so we can get into the thick of pre-computed lighting. When I go to build the lighting, it'll probably prompt you to approve Swarm on your system. That's just Unreal's lighting solution pipeline. So you'll see immediately this is really rough. The resolution for this is terrible. If I were to look at this, I could say this is possibly 1 square, 2 squares, 3 squares, 4 squares. It's probably 16 across, and it's a big square. This was designed to be placed onto an object this big. And so the lighting on this object would probably be okay. In fact, this one up here looks like it's lit just fine. But the fact is that we stretched out that light map that goes onto this object way more than it's supposed to. So in order to control for this, I'm going to need to select this surface, and I'm going to need to go down to Lightmap Resolution Override right here. And I think if it was 16 by 16, that would have been 256. So if we wanted to double it, we'd make it 512. But I'll bet that still also looks fairly bad when we go to build the lighting. So any asset that you're going to want to have a high fidelity shadow on, the override light map resolution is going to need to be set at a higher quality here. So it is substantially better. Basically, it's 4 times as many pieces as we had before. But I think that the idea of this being sufficient is that it's not going to fly in most high fidelity games. So if I went to 1024 and then I went to go build lighting again, you notice the lighting time is not actually that high for this, but as you add more static meshes that have more unique materials and things like that into the world, it can become a bit more time consuming. Once that finishes building, then we'll come through. You can see the lighting's even just a little bit more crisp, closer to that preview lighting intention. And if I wanted to, I could go build lighting and I could change it to production. That would give me a much higher quality, but it would still have that jaggedness because it's still beholden to the resolution on this. So the calculation of which pixels were bright or dark is going to be more accurate at the higher production value, but the number of pixels that I have to draw into is set by this resolution value. And if you have multiple assets that have shadows that overlap them, you're going to want to make sure that each asset has the same resolution, or at least the same texel resolution. All right, our reflection here is showing the wall without these assets in real consideration. That's because this probe is not very clear to see those. Being so far away, it loses resolution, so it's getting more shapes than it is, or it's getting more colors than it is shapes. So if we build reflection captures again, now I can see these pillars. The reflection capture is going to grab static details. So if I wanted to, I could go select a few of these ones here, and then I'm going to change them from static to stationary. And then when I go to build our reflection captures again, you'll notice that those objects are missing. And if I choose the floor here, and I change it from static to stationary, and I go to build lighting, or we can just start off with reflections. That's showing the blue that's underneath this is being reflected here. And then if I go to do build lighting, you'll see there's a few things are going to be missing from our computations now because we're using static lighting with non-static elements. And so you can see the shadows are cast on these other elements, but not on the ones that were being sent to the stationary light channel. So I'm going to go ahead and change this one light over here to stationary to see how that'll affect our build now. This is stationary, and when we go to build, we're going to go to lighting only. When I go to populate that, it will now show me the effect on stationary objects. And the stationary objects have lighting, but it is different lighting than the static ones. And that's because if I want to go at runtime, I could back out. I have this point light, and I can change the intensity of the point light. And you can see there's a threshold. It's going faster than I really want. But the lights for the static computed things are fairly similar. And then when I go to make these adjustments, the stationary ones have a more precise responsiveness to it because they can be of a different adjustment. I could change the let's go back to the light that I had here. Point light. When is it? I think we saw the outline. I think it's this one here because I can see the outline. If I change the lighting of this, it's casting the stationary light is casting lighting onto these. It's trying to colorize the static objects, but it's getting too much of the saturation, whereas the stationary objects are picking up the right amount. And so the idea that you want to consider, if an object is meant to affect the world through stationary property adjustments, then you can set the object to be stationary. If you want it to be static, then make sure the lighting that affects it is also static. We can run into issues with that. But we do have the ability to cast some shadows with a stationary light on movable objects, but it's a higher cost in performance. So with those in place, we also want to consider that the lights that we have, I'm going to use the spotlight because it's going to give me a better visualization for what we're about to affect. I'm going to bring our outer cone down here and bring our attenuation radius in. All right, so if I have this light, I'm going to add this to a stationary channel. I'm going to move this one from stationary to static, so we just have the one set of stationary lights, or one type of stationary light that's affecting these objects in the world. If I have this object here, and here, and here, and here, and here, you'll notice that I get this red X. And this isn't just for spotlights, but this is going to help to demonstrate the issue. So each one of these objects is affecting the poles here. So I have this middle pole is the one that's being hit by all of them. When we have objects that are overlapping, the issue that we're running into is the Lightmap channels that we're drawing into. Because stationary lights can modify things at runtime, they're affecting the map parametrically. And so when I have multiple lights affecting one thing, what we do is we reserve a Lightmap channel to determine what parameters that light will affect. So when I go to this asset, if I go down to Lightmap channels, let's see, our lighting channels, there we go. I have channels 0, 1, and 2. So there's 3 channels I can affect, basically an RGB value. And this is going to be stored inside of the Lightmap. The Lightmap is going to pack these things into each one of these assets, not just the shadows, but the different parameters from each light. So if I have a stationary object, it's going to be able to modify these dynamically, but even a static object is going to be affected by lights in different channels. So if I have this thing was, instead of casting on 0, was only casting on channel 1, it's still going to be affecting potentially the same things as these, because the calculation, I have room for this light and this light on channel 0, 1, and 2, and this one on, or 0 and 1, and this one on channel 2, but this one doesn't have any room on channel 0, 1, or 2 because they're already written up by something else. So I can move this one out of the range of these other ones so that they're not affecting the same thing. And I think we have 2 that are probably overlapping. And when I go to build, see if this will resolve the issue. There we go. So my error went away because I don't have overlapping effect for these things. This light over here, I turned it off entirely, so it doesn't have any lighting channels that it's affecting. But if I bring these down closer to the ground, I want to kind of increase the intensity of this so we can start to see what these are going to do. If I have these lighting channels, let's angle this over here. This is going to only be, let's see, we'll put this light only in channel 2. And we'll put this light only in channel 1. And then we're going to have this thing only in channel 1 and this thing in channel 1 and 2. And just to make it really overt, I'm going to change the color of this light to red and the color of this light to blue. So I'm going to go build lighting now. And I may run into that issue where some of the lights aren't being drawn because I've now pointed this guy back in some of these other surfaces. And so it may cause a lighting overlay. So when I come over here, you can see that this light should very readily be affecting this surface, and this light should be affecting this surface, but because I've put them in different channels, this is only broadcasting on the 2 channel, and this is receiving 1 and 2, and this is receiving only 1, and this one is only broadcasting on 1. So the light that this is casting here is being overshadowed, but we should have at least some purple if it's not obscured. Oh, it's actually probably being obscured by this. So let's pull that out some, and then we'll rebuild again. And you can see the small adjustments and needing to go back and rebuild, the time it'll take. It adds 10 to 13 seconds, on these early builds, but as you get further into it, it ends up adding minutes or half hours or an hour onto the project. So you can't work while that's going on because it's trying to calculate things as they exist inside of the world space. So it looks like it's being overshadowed by the red. Let's take this off. If I turn off channel 2 and it only gets channel 1, then you'll see that it will only receive light from this blue thing. And when I put channel 0 back on, then it's getting light from these other elements as well. So you can control the way that lighting is affecting objects inside of the world, but you have to be mindful that the lights have to match it. And if you have lights that are mutually exclusive, trying to attach to a single object, it might have some conflicting information about which one to prioritize in terms of the light intensity. So lighting channels are just something to be aware of as you go to build this out. We have consideration again with the reflections here. If you want to work with reflections in a larger space, let's bring these back into the fold for static consideration, so the reflection capture will get all of that information. If you want to consider that you have multiple reflective surfaces, a large reflection capture is still a good idea, but believe that there are nuances that the player will notice if they're walking through a space and they see the same reflection on one wall as they do on another wall, and they're not the same wall or even in the same room. So when we go to address this, we want to consider that reflection probes work with localized envelope priority, which means that if I have a sphere reflection that is of a smaller size, that I can have the sphere reflection closer to the surface that is most relevant to it, and it will get a reflection that is specific for that surface. So I can even drop this down to 50. Well, let's make it something we can actually see. So if I go to build the reflection captures and lighting, you'll notice 2 things. One, the reflection capture being built before the lighting means that the reflection capture is going to have outdated references, because the reflection capture is just an image, and so it's going to point at information that's not quite right. Let's see what I can get here. The reflection for these is so localized that it didn't even reach out to grab the information for the columns. But if I'm over here, you can kind of see in between this reflection probe here and this reflection probe here, I can start to see the columns in the reflection. But in each of those areas, the reflection is not able to reach over there because of the lighting. So when you work with the precomputed lighting system, building lighting, building reflections, being mindful of channels, the mobility of the assets that you're working with, and the lights that are affecting them, it's a larger world of consideration than I like it to be bright in the corner. So when you think about working with precomputed lighting, make sure that you're approaching it intentionally. You get to use more lights, and of course that allows you to have a higher fidelity, but it also requires you are more careful with the way that you implement those things, not only for performance, but also for viability. So I hope this helps give you an idea of some of the things that are going on in precomputed lighting, and then possibly some ideas of tricks you can use to optimize your project. I hope that it lets you go out there and keep building.